Hi, I'm Maggie Maggio, artist and art educator with Smashing Color Studio. For the last 20 years, I've taught artists around the country how to mix colors. I started using the red, yellow, and blue traditional mixing system, and about 10 years ago I switched to cyan, magenta, and yellow. One of the hardest things to understand in a class where you're using magenta instead of red is that red is the primary of light, not of pigment. Magenta is the color that is used in subtractive mixing systems as a primary color. Why is it so hard to understand that magenta is the primary and not red? Welcome to Mission Magenta. I've divided this into 3 narrated PowerPoint presentations. The first, what magenta is. The second, what magenta is not. And the third, how to add magenta into your classroom. I've got a few videos thrown in, but for the most part, I'm just going to be talking to you over my PowerPoints. What is magenta, and why is magenta not on the rainbow? When you look at the rainbow, you see red, orange, yellow, green, blue, indigo, and violet. That's because it's part of the visible spectrum, and the visible spectrum is measured from the short blue wavelengths through the medium length green wavelengths and the long wavelengths that are red. What is happening when you see this spectrum split is you're missing magenta. Magenta comes where the red end of the spectrum and the blue end of the spectrum overlap. And that overlapping happens in our eyes. It happens because we have 3 kinds of cones. We have cones for the short, medium, and long wavelengths. So when these cones are triggered, we see different colors. If you trigger a red and a blue cone at the same time, that's when you're going to be able to see magenta. Magenta is the overlapping part of the spectrum that is actually considered extraspectral or non-spectral. It's not on the spectrum. Here is physicist Robin Marjorie Banks to talk about how these colors overlap.
So here what I have is 3 slide projectors that project the 3 colors. The blue is fairly pure color, the red one is fairly pure as well, and fairly pure green over here. But as they overlap, you see that blue plus green together gives you a different color, the cyan color that's here. Red plus green together give the yellow color down below, and red plus blue together give the magenta color that you see at the left. But all 3 of those colors, as they overlap, give a white spot in the center. Now if we subtract one of those colors, if we take out, for instance, the red, then that white spot turns cyan. If instead we subtract the blue, that white spot turns yellow. If we subtract the green, that white spot turns magenta.
In the RGB system used on the computer, magenta is 255 red, 0 green, and 255 blue. Or in hex, it's FF00, FF. 21st Century Magenta in Wikipedia has these color coordinates. You can see the FF00, FF. The 255, 0, 255, and then the CMY 0, 100, and 0. That's because the 2 systems are reciprocal. We have our light mixing system, which is additive, which means we start with dark and we move with more light into white. So as the colors mix, they go from dark to light. They add light. In a subtractive system, we start with white. The colors are added. As they are mixed, they get darker and darker until they get into something that's very dark, like a black. In the CMY system in Paint, you'll mix colors using just the cyan, magenta, and yellow to get those dark colors like black. But in printing, in the CMYK system, the colors are transparent, and as they overlap, they never get dark enough, so a key color is added. When you put these 2 systems together, you get the 21st century color wheel, with the flow of color now moving from yellow through red, magenta, blue, cyan, and green. It's this relationship that does not change. What does change is the names. So we go from Roy G. Biv to making the shift to RGB/CMY. I have the book The Colorist by J.A.H. Hatt. It's written in 1905 and it already shows the new color names of magenta and a cyan blue. Where did these new color names come from? They came from the discovery of aniline dyes in the mid-1800s. The dye fuchsin was discovered, and it was named both magenta and fuchsia. These color names are synonymous. Magenta and fuchsia are the same thing. The traditional red, yellow, and blue system is changed to make magenta the primary and red the secondary. That means there's new hue names and a new hue circle for the 21st century. So that's what magenta is. Now I want to talk to you about what magenta is not. We want to start with magenta is not a pink. I have a collection of children's board books and they all show pink and magenta at the same time. This is an issue for me because pink is very much a gender-biased color. When you see pictures of little girls surrounded by all their pink things, you see how pervasive this idea is that pink is all about little girls. If we're going to be starting to include magenta in the classroom, we have to be clear that magenta is not pink. Even though here the Pantone pink, the shocking pink, and the hot pink out of Wikipedia look a lot like magenta, they're really not. Magenta is not red. Red has spectral coordinates unlike the magenta. Because magenta is extraspectral, it doesn't have any numbers associated that can be measured on a spectrometer. When is magenta mistaken for a red? In the double primary system, in red, yellow, blue, you want to have warm and a cool of each primary, and magenta is mistaken as a cool red. This is not really true. Reds are actually magenta mixed with yellow. Here we have quinacridone magenta, a pigment red 122. It's shown in the center along with 3 yellows that have been mixed with it to make bright reds. If the definition of a primary is that it cannot be mixed, then in this case, red is not a primary. Magenta is also not purple. Here, compare these two, the purple to the magenta, and you can see purples are magentas mixed with blues. Here we have the quinacridone magenta mixed with 3 different blues to make bright purples. So that's what magenta is not. Now let's take a look at adding magenta into the classroom in age-appropriate ways. For the subtractive mixing of color, it's as simple as supplementing all of your materials with their magenta equivalents. Bring those into the classroom, let the children play with them, and they will soon discover where magenta lives in that 21st century system. What's a little bit harder is bringing in the idea of how to mix colors in light. Now, traditionally this would be considered a science component, but I believe strongly that we want to start integrating the science of color and the art of color, bringing them together because our students are going to have options of playing with digital media as well as traditional media. I have found that the best way to introduce the idea of light mixing is with, of course, the handy-dandy iPads. So let's do a little slideshow of ways to do age-appropriate inclusion of magenta in the classroom. In the early years, it's all about giving students the opportunity to discover magenta by finding the right magenta to include with all the other materials. Then it's simply a matter of doing traditional projects with a new color, handprints using magenta and yellow to make red, or a box of 24 crayons so that you can get the right colors for a modern color wheel. Once students have been introduced to magenta, it's time to start exploring. Both the subtractive and additive system, and the iPad is great for this. You can put film on and try the different overlappings, and then do a new color wheel inspired by George Field's flower. You can also do additive mixing by bringing up single color screens on the iPad, making a tent. The color underneath in this case is a beautiful magenta, and bring up their computers and look at the additive mixing system on the computers. By middle school, students are old enough to experiment with color scales. Here's a color scale in polymer clay, my medium. It combines a fuchsia clay and a zinc yellow clay to make red in the middle. There are also experiments that can be done with light and shadow. For example, experiments in colored shadows can be turned into still lifes and painted by the students. Once older students have a firm grasp of both the additive and subtractive mixing systems, they can start experimenting with the partitive or optical mixing systems. Color curriculum in the 21st century supplements the traditional standards. The main point is that you integrate art and science, use the RGB CMY color wheel, and make it really fun for your students. Thank you for joining me on Mission Magenta. Your mission, should you choose to accept it, is to explore 21st century color with your students in the classroom. I've provided a Pinterest page with the resources and all the details for the different experiments that I've talked about in the presentation. I invite you to add to that Pinterest board anything that you do in your classroom that has to do with this subject so that we can continue with Mission Magenta. Thank you.